Okay, 7.4, adding and subtracting rational expressions with polynomial denominators. So the only thing that we're looking at that's different in this scenario is the fact that instead of just a single variable or variables multiplying together in our denominator, now we're going to have denominators that have multiple terms. So whether they're adding or subtracting, we're going to have multiple things going on, which makes things a little bit more challenging. Another thing that makes things challenging when it doesn't stay zoomed in. There we go. So remember from our previous lesson that we said that there are 4 steps. 1, factor anything that you can. 2, state your non-permissible values. 3, you're looking for your lowest common denominator. And 4, you're going to simplify. So we look at the denominators in example 1a, and I'm not able to break them apart anymore. There's no common factor that can go into either of those terms. I can't break it up anymore. Same thing happens in my second rational expression. I can't break it up anymore. So I can skip to step 2. What are my non-permissible values? Well, they are that p cannot be 2 or -1. My lowest common denominator needs to include all the factors of both denominators, but as few times as possible. In this particular case, p minus 2 is not present at all in my second expression, so I just need to account for both of them entirely. Now, please note, p is not common, because we have to account for the fact that we are subtracting as well. So if we had subbed it in a value such as like p equals 6, then we would end up with 2 denominators, one being 4 and the other being 7. These are not the same thing, so we cannot assume that just the p part is the same. We can't say that p is a common factor. Okay, so if this is my common denominator, when I go to actually analyze this, p minus 1 over p minus 2, I need to introduce p plus 1 to the denominator. So I'm going to introduce it to the numerator as well. And for my other rational expression, I've got p plus 1 in the denominator already. I need to introduce p minus 2. I'm doing, again, multiplying by 1 in order to be able to make this possible. So I can write this again all over p minus 2, p plus 1. If you want to write it out just to kind of make a little bit more sense of it, you can do this step. You do not have to do this step. If you can kind of spot what's about to happen, go right ahead. Because we've got binomial times binomial, binomial times binomial, binomial times binomial. We are going to FOIL each of these. We're going to distribute within there, which means that I end up with p squared minus 1 plus p squared plus p minus 6 all over p squared, not r squared, p squared minus p minus 2, which can even be simplified from there to collect like terms in the numerator. We've got 2p squared plus p minus 7, all divided by p squared minus p minus 2. And that would be my final answer, along with the fact that p can't be 2 or -1. Okay, so that lowest common denominator is your key step again, because that's going to influence what your numerators end up turning into. For example B, we're going to do step 1, and for the first time we're actually going to have to factor. Now the numerator looks like it should maybe be a difference of squares, but since 20 is not a perfect square, it is not a difference of squares. So my numerator can't have anything done with it. I've got y squared minus 20. But my denominator is a perfect square because 4 is also a square. So I've got y plus 2 and y minus 2. Plus, I can't factor my second expression at all, so y minus 2, y plus 2. Now, I'm going to pause here for a couple of reasons. Number one, we can't cancel y squareds for the same reason that we couldn't do it in the previous lesson, where we're doing other operations as well. This whole denominator applies to the y squared. This whole denominator applies to the 20. We can't break it into pieces. It's not like multiplying and dividing. Similarly, we can't cancel out the y's here, and we can't simplify like 5 and 1 or 1 and 1. None of that's happening. Don't do that. Okay, the second thing I'm going to point out then is if we're not allowed to cancel within a rational expression when we're adding and subtracting in there, then we're also not allowed to cancel diagonally, because again, it's not an opposite operation. So we've got to leave it like this. Step 2 is our non-permissible values. So we've got y can't be positive or negative 2. My lowest common denominator. In this case, because we actually see y plus 2 showing up in both, I'm only going to write it once, and that accounts for both scenarios. But then I also need y minus 2 because of that first expression. So when I go to actually simplify this, I've got y squared minus 20 divided by y plus 2, y minus 2. That doesn't need to change. I already have my common denominator there. But y minus 2 over y plus 2, that is missing a piece. I need y minus 2 to still show up in the denominator. And so what I'm ending up with is y squared minus 20 plus y minus 2, y minus 2, all over y plus 2, y minus 2. From here, again, we're going to FOIL. So we get, and we can FOIL the denominator as well. And we can collect like terms. Now you can end up with y terms showing up in both of them. That is a possibility. We just haven't run into that yet. 2y squared minus 4y minus 16 all over y squared minus 4. Now you're like, okay, but I can actually take out a 2 from my numerator. And you would be absolutely correct if you're thinking that. But it doesn't do me any good to factor out that 2 because I cannot factor it out of y squared. So there's no way of reducing this entire fraction at all. So I'm just going to leave it as it is with my non-permissible values of y can't be positive or negative 2. So that would be my final answer. So again, we look for factors to try and break things up so that we can A, determine our non-permissible values a little bit easier, but B, it also lets us determine our lowest common denominator a little bit quicker too. So let's see what that looks like here. We've got 2 and then x minus 3, that's unfactorable. 3x is also unfactorable, but this technically is a perfect square. Now it's also kind of backwards, so I'm going to take out a negative and then I'm going to factor it. So that negative switches the order. So instead I'm dealing with x squared minus 9. And then the reason I want to switch the order is so that it looks more like my denominator over here. So I've got x plus 3, x minus 3. Now a couple things can actually happen here. The nice thing about having two negatives is that they make a positive. So now we're going to be adding, so that simplifies things. But then when we go to talk about our non-permissible values, life becomes a little bit easier too because I've factored things. So in this case, my non-permissible values are x can't be positive or negative 3. So we're seeing a lot of those difference of squares to start off with. So make sure you can recognize the difference of squares. Two squares, one subtracting from the other. Okay, I can also determine my lowest common denominator by looking at my denominators here. I've got x plus 3, x minus 3, and again I have x minus 3 showing up in both, so it's already accounted for it, so that's all I need. X plus 3, x minus 3. So I've got 2 over x minus 3 already, so I just need to introduce the x plus 3 to this fraction, this rational expression. And our second expression already has the whole common denominator, so we are good to go. 3x, x plus 3, x minus 3. Leaving us, and this time I'm just going to distribute in the same step as foiling out my denominator. Okay, I'm going to skip ahead a little bit, and I'm going to end up with 2x plus 6 plus 3x all over x squared minus 9. From here I'm going to collect like the terms, and my final solution will then be 5x plus 6 over x squared minus 9, where x isn't positive or negative 3. Okay, so that's how we do our common denominator. We're always looking for all the different factors need to contribute. We've got 7 over x squared minus 49 and 3 over x squared plus 14 plus 49. So I'm going to notice right away that this is my difference of squares, and this is actually a perfect square. So I know I can factor both of those denominators now, so we've got a little bit more to do. So I've got 7 divided by x plus 7, x minus 7. In my first rational expression. My second expression is going to be x plus 7 squared. Okay, so now that I've factored, same process, non-permissible values. In this case, it's still dealing with only two numbers with opposite signs, so x can't be positive or negative 7. My lowest common denominator in this case is going to be a little bit more complicated. So I have x plus 7 showing up in both, but I actually have it twice here. So I need it to show up twice in my common denominator. In addition to that, I still also need my x minus 7. So I'm going to have a trinomial in the denominator. When we run into this scenario, you are more than welcome to leave it in factored form. Okay, so let's see what happens here. I've got 7, x plus 7, x minus 7. In order to make this into my common denominator, I still need an additional x plus 7. My second expression, I've got 3 over x plus 7 squared. I'm missing that x minus 7 component, so that's what I'm going to introduce. Okay. So again, I'm going to distribute and kind of skip some steps in terms of space. I am also going to expand this, so that would be x squared minus 49 times x plus 7. So that would be x cubed plus 7x squared minus 49x minus, and you'll have to use your calculator to figure out 49 times 7. Okay, and that gives us 343. So that's my denominator. So you can FOIL it out. It is possible. Okay, in addition, I'm going to expand these guys and distribute. So what I'm going to have is 7x plus 49 plus 3x minus 21, all divided by x cubed plus 7x squared minus 49. Oops. 49x minus 343. If I simplify this, these two are going together, these two are going together. So I've got 10x and then positive 28 all over my crazy denominator. And don't forget your non-permissible values. Okay, so how are we feeling? It looks a little crazy. Again, you don't have to do this part. Okay, if you leave it in unexpanded form once we get to cubics, I'm totally okay with that. Our last example. Okay, so when we look at E, again, you'll notice I missed that 8. I don't know why these digits keep disappearing. The rest of it looks okay though. First thing we're going to do, factor that denominator if we can. And luckily we can. So we've got n and then plus 6, n minus 3, subtracting n minus 2 over, and then we've got n plus 5, n minus 4. Now before you are like, oh my god, I see something to simplify this. Okay, slow down. Non-permissible values first before we start canceling anything out, which are in this particular case -6, -5, 3, and 4. We've got 4 non-permissible values. Now you can get excited about that. So it means that we can actually simplify that first rational expression. Why am I getting excited about this? Well, that means that my lowest common denominator has one less binomial in it, which just means that everything's a little bit simpler. Okay, so now I can talk about lowest common denominator. And in this case, it's going to be n plus 6, n plus 5, n minus 4. So I'm going to take my first expression and I'm going to multiply it by not only n plus 5, but also n minus 4, because both of those pieces are currently missing. My second term, I've got n minus 2 over n plus 5, n minus 4. This one's a little bit more manageable. All I need to multiply it by is n plus 6. That's all that's missing from my denominator there. So from here, I'm going to expand this. Well, luckily I already have that from my original question. That's going to be n squared plus n minus 20. I'm then subtracting, and I'm going to FOIL this out. So I've got n squared plus 4n minus 12 all over my triple denominator, which I am not going to FOIL out. Again, you are welcome to, but I am not going to. Last but not least, I'm going to collect like terms. Now remembering that I'm subtracting here, n squared minus n squared actually cancels out. So the subtraction is applying to everything inside the bracket. N minus 4n is negative 3n. And then negative 20 subtract negative 12 is the same thing as adding 12. And so we've got negative 20 plus 12, which is negative 8, all over our ridiculous denominator. And our non-permissible values. Don't forget that 3 was also in there. There we go. So you got practice questions to do. You've got the A5 assessment to write once you're confident with all of these skills. And then we'll move on to the last part of the first half of this unit, or the first big concept of this unit. And then we get to move on to graphing after that. Okay, so give it some practice.